I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn problem solving strategies. Here is a very interesting question, which is x square minus x minus 1 to the power of x square plus 2x minus 3 equals to 1. So that's an equation. We need to find the integer solutions for this particular equation. I'd like you to pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now let's look into the strategy which can help us solve this particular question. We are given on the left hand side an equation which is equal to 1. So basically, if you look into exponents, so any base to the power of x, let's say a, will be equal to 1 for which conditions? That is what we have to look into. Well, the conditions could be, which I'll consider them as cases, as case 1, that the exponent a is equal to 0. Anything to the power of 0 is 1. The only thing is, for that value, b is not equal to 0. Because 0 by 0 is not defined. Correct? So that also gives you a concept. Now, second case could be, let me write case 2, that is b equals to 1. Now, if b is 1, then we know 1 to the power of x is always equal to 1, correct? So that will satisfy the equation. Now, could there be any other case which we should consider if we qualify this particular question with find all the integer solutions, right? So find all the, let's say, okay. So yes, there is one more case which we should consider, and that is, I'll put this as case 3, when b is equal to minus 1 and a is even. So minus 1 to the power of even numbers is always positive, right? So that will give you plus 1 as your answer. So these are the 3 different cases which we need to analyze to find all the possible solutions for the given condition, right? So I hope it is absolutely clear. Perfect. Now let us look into the solution for each case one by one. Here is the first case. So case 1 for us is that exponent is 0. So exponent in this case is x squared plus 2x minus 3. And we want to make that as 0, right? So we're saying b to the power of 0, which is always 1, right? And of course, b should not be equal to 0 for that particular condition. Let's factor this. The product should be minus 3 and sum should be 2. That means plus 3 times minus 1 can work, right? So I can factor this as x plus 3 times x minus 1 equal to 0. So that gives you 2 possible solutions, one of them being x equals to minus 3, the other one being x equals to 1. So those are the 2 solutions, and we know for these solutions we can check that x square minus x minus 1 is not equal to 0. Correct? For x equals to minus 3 and 1. Well, in fact, if you look into x square minus x minus 1, it does not have integer roots, right? And therefore, there will not be a conflict also. Clear? Okay. So one part we have done. So we noted that there are two solutions, x equals to minus 3 and 1. So let me write down here as our solution x equals to minus 3 and 1. We got two of them. Okay, now let's look into the second case, which is when base is 1. In that case, the answer is going to be 1. So that is to say, 1 to the power of x is always equal to 1. So in this case, which is case 2 for us, the base is x squared minus x minus 1. We want that to be equal to 1. So let's simplify this, bringing all the terms together, and then we'll actually factor this and solve. So we get this as x squared minus x minus 2 equals to 0, and this can be factored. Minus 2 plus 1 can work for you. So we have x minus 2 times x plus 1 equal to 0. That gives you two solutions, which is 2 and minus 1. Clear? Perfect. So let's include these two solutions also, which is 2 and minus 1 in our solution. So we get 2 and minus 1. So we now have 4 solutions. So we've done case 1 and 2. Let us now look into case 3, where b is negative 1 and the exponent is even. So let's equate the base to negative 1 in case 3. So that is x squared minus x minus 1 equals to negative 1. So it gives you x squared minus x minus 1 plus 1 equals to 0, or x squared minus x equals to 0. Taking x common, we get x minus 1 equal to 0. So that gives you two answers, x equals to 0 and x equals to 1. Now, what we're trying to say here is that the base to the power of a, so we are saying base is minus 1 and a is even. So we check base is minus 1 for 0 and 1. So if I substitute 0 here in x squared plus 2x minus 3, if I put 0 for x, then this gives you minus 3, which is odd. And since minus 1 to the power of odd number will be negative 1, not positive, so that is not a solution. Perfect. If I substitute 1 here, then what? So in x squared plus 2x minus 3, if I substitute 1, I get 1 plus 2 and then minus 3, which is 0. So anything to the power of 0 is a solution. Minus 1 to the power of 0 will also be a solution. So yes, 1 is a solution, which we have already considered in case 1, correct? So as you know, in case 1, we did get one of the solutions as 1. And therefore, we'll end up with 4 solutions in this particular case, which are minus 3, 1, 2, and minus 1. Is that clear? So the summary of this can be written as this. We worked on the equation x squared minus x minus 1 to the power of x squared plus 2x minus 3 equals to 1. And for this to be true, we are looking for something like b to the power of a equals to 1. And for that, we had 3 conditions. We worked out for each condition as shown here and found that the solutions could be minus 3, 1, 2, minus 1. In the last case, we got a solution which was 1, which was also considered in case 1. So in all, we have 4 solutions for this particular case. So I hope you understand and appreciate it. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. You can always join my classes by sending an email on the address given. Thanks for your time and all the best.